Again. I know that all of you guys did this last year, whether it was my honors group, the AB groups, or the regular algebra 2, you guys did something with functions and function composition. It is also, for those of you guys that are juniors right now, it is a real big thing you're going to see on the ACT. For those of you guys that are seniors, it is something you probably saw on the ACT, and if you're retaking ACTs, it'll help you get better. It really will, okay? This is one of the most common things as you go through. Sir, I don't have one. Anybody got a pencil phone? Test on the spot. She's the best. Unlike the rest of her siblings, they're all weird. Kind of like yours. Well, you don't talk very much either, so it's okay. Anyway. I know you've done this. You're just going, and I know how you guys think, and I know that just with this first month with this class, you guys get a little antsy when you see things written differently. I'm trying to get you guys to understand that this book is very technically, written in a very technical manner. It's going to be how you guys are going to read a lot of your textbooks as you go forward, whether they're science or math and whatnot. As you guys get into college, textbooks suck. They're awful. They're very difficult to read. The more time you spend just kind of listening to how the professors talk and how things go through, the better off you will be with it. You'll have to believe me on this one. You've seen this, where you have two functions and they're going to ask you to do function notation with them. Where it's asked you, if you have your two functions, f of x is 2x plus 3, and g of x is x squared minus 1. What you have done before is that it will ask you to take f of x and add g of x to it. What do you think that would look like? Correct. That's all that is. I know you guys have seen that. What happens here is that this is what we call function notation and function operations, okay? You're taking two functions, you're doing some combination with them. In this case, it's asking you to add the two functions together, which means, just like Maddie said, I'm going to take the f of x, I probably should have spaced this out a little bit more. Give me 1 second, fix that. There, now I have some more room. So if I take that f of x equation, I just write it down. 2x plus 3. And I add to it x squared minus 1, which gives me a final answer of? And you're done. Composite of functions. You just put it together. That's it. Okay? It's not crazy. What do you think it means when you have subtraction?
2x plus 3 minus x squared minus 1.
What should you do to the second function though?
Well,
You're right. Throw it in parentheses. Okay? Good. When you have that second function, we have our first one, 2x plus 3. I'm subtracting the whole thing, which is x squared minus 1. Please remember to distribute your negative. Please, 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 oh, pretty please with sugar on top. That way you don't mess up. Okay? So you wind up with 2x plus 3 minus x squared plus 1, and you just rewrite and you're done. I was seeing if you were paying attention. Congratulations. Now let's just get how's that? So this gives me a negative x squared plus the 2x plus 4. And that's how those two look like. What about multiplying? Well, you would just multiply. Okay? Move this up so I have some room here. And I'll go back to dividing here in a second. It would be, was it 2x? Thank you. Let's multiply them together. In this case, they're two binomials, so you just FOIL it. Okay, you just have to FOIL it out and combine like terms. As we do that, we get 2x cubed minus 2x plus 3x squared minus 3. And then just to be on the proper side of math, we would just put it descending order. Okay? That's more of the proper way of doing it. 2x cubed, 3x squared, minus 2x, minus a 3. Okay.
I'm gonna start getting more confusing.
Not really. What's going to start, like I was saying a second ago, what's going to start being a little bit more confusing is how they write it.
Yeah, like, no, like, what's gonna write, like, F parentheses G parentheses X, F parentheses parentheses.
Yeah, we'll get into it. But it's a matter of working your way out. Once you start in the innermost parentheses, you start thinking about the disordered ops. You think it that way, you just go backwards. That's all it is, disordered ops. And then the last one was f of x divided by g of x. You do the same thing. Here we had 2x plus 3 divided by x squared minus 1. In this case, there's nothing I can do. Do you remember the reason why there's nothing I can do here? Let's see if you know this one. Say it again.
Just say.
What's right? I can't cancel anything out of the expression because of the addition. I can't simplify anything of the addition. But take a look at the degree. Take a look at the degree. The degree of the denominator is bigger than the degree of the numerator. That's kind of like saying, can I take 8 into 3? No, same idea. Yes, sir.
It's not from 0 practically.
Right. That's what Izzy was saying. It's the exact same idea. You cannot simplify anything in here because these are parentheses. And you cannot simplify with the addition. Nothing you can do. Every once in a while, you might find something where your two functions, they could all have even coefficients. Maybe you can divide out of 2. That's about all you can do sometimes. When it comes to like the long division or the synthetic division, ew, I love that stuff. It's great. If that comes up, we'll talk about it. I don't think it comes up a whole lot right away. So like I said, this is everything you have done. This is nothing new. What's going to be new is how they write it. They write it differently. They write it, instead of f of x plus g of x, they write f plus g of x. No, this is in your book. I just want you guys to see, if you want, it means the exact same thing, okay? It means the same thing. What they're doing here is they just write it differently. That's it. It's the only thing that's different from what we've been doing. If you see f plus g of x, it's the same thing as f of x plus g of x. Because if you look at that, what did they distribute out with the f of x and g of x? Yeah, they're just simple. They're using it as like a GCF type deal. That's it. It's the same process. It's not hard. Yeah, by using calculator. He's getting good at calculating the graph. He knows he's better than that. But you see, just like he was just saying, notice all they did is they pulled that out as like a GCF, if you will. It's the same thing. All right? It's just a simplified way of writing it. That's all it is. Okay? So when you see it, just remember there really is x's with all of it. Okay? If you finish that up, Colton, I would, like I've told everybody else, I'd give you time to go back and look at that with your calculator if you want. Take pauses, take batteries. Does that make sense? That's the only thing that's different, guys. That's it. Okay? The rest of it's really, really easy. Yeah. Yeah. Remember, all they did was just take out the, they're just simplifying it like the GCF. You know? Okay. That's all that means.
Oh, can I?
I'm changing it a little bit. I'm going to change up the problems in there. There's a couple of things on there that we don't need to do. I know. I'm changing some of the numbers on it. Mr. Fontana and I have, are, like I said, the assignments that are on here, we're adjusting as we're going because there are certain things that we're not covering through. I wasn't even throwing it. That's fine. It's all good. All right, so let's just do an example. Like I said, we have f of x is 2x plus 1, g of x is x squared plus 2x minus 1, and I want to find what is f plus g of x. This is how it's going to be written in the book. This is how it's going to be written in the book as opposed to what I showed you 5 minutes ago. So remember, when you see that, that just means what?
F of x plus g of x.
That's it, bud. That's it.
I hope it's that simple, because
So that would just be x squared plus
Yeah, that's exactly it. I'm trying to take the scariness away from this by showing you guys that you already know how to do this. It's just a new way of writing it. A lot of pre-calc, really, first semester pre-calc is all Algebra 2 review. There's only a few things that are really new to you. Difference quotient, slope of the secant line, that delta f of x. Bless you. There'll be a couple little things here and there, but for the most part, it's all what you did last year at just first semester wise. Okay. So here you wind up with 2x plus 1 x. And like Cindy said, when you combine like terms here, you get x squared plus 4x, and you're done. Okay? We'll begin to do this stuff a little bit more into tomorrow when we do the actual, Terry was talking about with like the f of g of x. They write it a little bit different as well, but it means the same thing. We'll do the pure composites we need tomorrow. Domains. What's your domain mean again? Exactly. So when they do the division stuff, they like to ask you to list out the possible domains because there are going to be domains that it won't work. Right? So remember that that's what one of the parts will be on the questions. They'll say list the possible domain, usually only with division. Okay? Let's just do one of them because we're running a little short on time. Do you want to do the f over g or g over f? Okay, let's do the f over g.
Or whatever one will be harder.
I don't know. I haven't done that. We'll do f over g. Why not? That means we have square root of x over the square root of 4 minus x squared.
don't we just off the bottom? Don't we just say bottom equals 0?
For your domain?
Yeah.
Yeah. So what can't x be?
X can't be 2.
Or?
Negative 2.
Or
Plus
negative.
or minus.
So in a case like this, you wind up you can rewrite. Since you're just doing composite, I'm not worrying about anything crazy. I cannot simplify that x in the x squared. It does not work. And like I said, the domain here for this case is you set your denominator equal to 0. So 4 equals x squared. Well, that means plus or minus 2 is x. Therefore, it's going to be all real numbers except plus and minus 2. So basically, you can write it as x can't equal plus or minus, oops. And I'm okay with you writing it like that.
Or all the R.
Yeah.
Would, except 2.
Yeah.
Except plus minus.
Yeah,
But,
either way is fine.
Could, isn't that also true because if you can't get, if you did like, say you did,
You're thinking range.
no, watch. 4 minus, like, okay, let's say, like 4 minus 5, okay, x equals 5. Then we do a negative number. You can't do a negative square root without being a imaginary number.
Correct.
So it couldn't be any of those either.
Okay, so we know we can't have plus or minus 2 or
Any number greater than, I don't know.
good. do you got? Kathy?
Just explaining what's going on here, 'cause sometimes it's lost.
Okay. What we're doing here is when we're finding the domain, is that we're trying to figure out what are the possible values of x. What are the possible values of x?
Okay.
In order to do that, it's normally set the denominator equal to 0. Because you don't want to divide by 0. Okay? So if you have the denominator, you set it equal to 0, what I did is I add the x squared, square root it, and I get plus or minus 2 for my values of x. Okay? Now, what he was saying is, what about the values that are bigger than that? Well, what about the values that are smaller than that? And he's on the right track. Because you're right, you can't just have x can't equal 2 or negative 2. It has to be between 2 and negative 2. Think about that. Because if it's bigger than it, it won't work. And if it's smaller than it, it won't work either, will it?
Wait, how do we do that?
Yeah.
I think you're really trying to make me trip and fall.
Yeah.
How am I figuring that out?
So like, every time, like, you get two answers for the x, it has to be in between.
Well, no. What I'm hoping that you guys are going to do is stop for a second. That's why I stopped. I just kind of kept talking. I wanted to see if it makes sense. See if you look at your answer and see if it makes sense. Because what you're doing here, if I'm looking at that range of values, okay, if x is 1, it's real easy. I get 4 minus 1. It works. If x is 5, I get 4 minus 25, and I get a negative value. Can I take the square root of a negative? No. Now, if I say that it's a negative 5, 4 minus 25 again, because negative 5 squared is still positive. So there's going to be certain times where you have to stop and think, does the answer make sense? And you have to go back and think about it. That's all. It's probably because you have a square term here. If it was just 4 minus x, we'd have a singular thing that won't work. There's only one thing. Whereas you get something going in here, you start to have, does the answer make sense? Okay.
So wait, what's actually the correct answer?
Right here.
So, the one I-
You were saying, yeah.
So if he just would have wrote, like you said, just the x does not equal plus or minus 2.
That would be incorrect because aren't there infinite other numbers that aren't, you know what I mean? But there are also infinite numbers between plus or minus 2 also, if you want to go that way.
You can just write x.
No, because there are other numbers that it won't work for. That was the whole point of trying to get you guys to look at the answer and maybe see if it actually does work. That's my answer. The domain can't be x, but x is bound between 2 and negative 2. Okay, let's see. Where's the button for that? There it is. Sorry. Okay. All right. So here's what I want to do. Take your calculator out and take a look at this. And I'm going to type this into my calculator. I know I have a square root. Where's that button? I have square root of a fraction, which I believe I have a button for that up here, don't I?
Or you could just press control division.
There we go.
Sorry.
I have a fraction. Listen. Why is this?
Me too. What just happened?
I didn't know how to get out of this other fraction.
Why are we using this color?
This is what they're supposed to be using. Let's make a petition.
No, like.
I didn't know how to get rid of another graph.
Bring back the.
All right. So I'm going to do a fraction.
Like menu.
This of a. What was it? What was the numerator? X.
And then how many more?
Go to menu like table set or something. Graph and then like function. Graph entry.
Oh, it has two graphs.
Analyze graph. They come play musical chairs all the time.
Yeah.
It's not just this. The graph stuff works, guys. It's just the software that they gave me to make this work hasn't been working since I have tried to upload it. So.
Mr. Murphy, did you do what I asked? Did I-
Wait, I don't.
No.
Mr. Murphy, is this what you wanted to do?
Maybe it'll work.
Because it said that there's. Well, I got something landed on.
It's just too much.
Why didn't you get it?
I mean, plus, minus, divide, fraction, and square root. Yes.
I didn't know there was a table on this. Like that's like really on fire. Yeah, this is like the fire department. Just can't get over it.
Hey, Jerry.
Anyway, what's happening here, since you have your domain, when you're going to a problem like this, you have to stop and think, does your solution make sense? We still find the possible zeros the exact same way. You set your denominator equal to 0. We got x can't be plus or minus 2. The problem comes in because the entire problem has a square root to it. Remember, you cannot take square roots of negative values. So these wind up with your ranges, okay? If you pick a number that winds up being bigger than 2, come on. If you put in a number that's bigger than 2, you wind up with a negative value. Can you take a negative root? No. Okay. If you pick a number that is smaller than 2, you get the negative root. But that's why it's giving you that imaginary part. But here's the other thing. The reason why, if you look at your graph stuff, you had some of those, you get a little funkiness. I just want you guys just to stop and think what will work, okay? We will do more of the pure domain stuff tomorrow. Because we need, I'm going to need more time to re-explain all that to you guys. The ones that I had,
Post-it note fell off. On that homework sheet, let me change those numbers that you guys have on.